This is pre-calc. This is your little lecture for lesson 84. So it's about factorable expressions and sketching sinusoids. So they're kind of warning you at this point that they're probably going to throw some things in where you're going to have to factor. So you know how to factor. Like I could, if it's convenient for me for some reason to have a sine squared x in my problem, then I could always just simply rewrite this as sine x times sine squared x. Now sometimes it's convenient. Think about when we're doing those things where it says show, you know, like this one, it says show that sine x minus sine x cosine squared x equals sine cubed x. These show ones, those are those ones that we did one today, where we're kind of replacing, we'll take something and replace it with an identity or something that it's equivalent to kind of manipulate the left-hand side to make it look like the right-hand side. So they're kind of cluing you in that if you see difference of squares, you might want to think about factoring it. You know, you see something like that, that should be difference of squares. You should recognize this one also as difference of squares. That's also one of our identities, though, isn't it? Like when I look at that, 1 minus tangent squared theta. No, it's not one of our identities. 1 plus tangent squared theta is secant squared theta. But anyway, say you want, for some reason, if it's convenient for you to rewrite this in factored form, you want to be aware that you can use difference of squares on a lot of these. If you have one like this, you can just factor out the sign. One like this could be difference of squares. This thing is actually a perfect square trinomial. I didn't recognize it, but see the front is a perfect square. That's a perfect square because sine squared times sine squared, and that's 2 times the front times the back. So, or the square root of the front times the square root of the back. So that's perfect square trinomial. And then this one was difference of cubes. And if you remember from algebra 2, that we have a little pattern for difference of cubes. So I love these. These will be really fun. Maybe we'll do one in a little minute here. Here's sketching sinusoids. So just so you know, these things kind of, they hurt my brain a little bit, but I do like how the author of this book suggests that you sketch your sinusoids. They're saying if you had to sketch this thing, there's 2 ways to go about it. You could just label your paper and maybe use some graph paper or something and have it all labeled and then do it that way. Or you could just draw the wavy line and then put the labeling in on top of your, you know, your sinusoid that you sketched. So the author of the book's kind of suggesting that this way would be the easiest way. So what they do first is they just, they'll just, over here this is not the y-axis, this is just showing, basically it's to show the midline, isn't it? It's to show the midline and the amplitude. And then they go ahead and put in some angle measurements on it. They just put it how they want. And then if the y-axis is going to appear on your paper somewhere, you can decide, you know, kind of sketch it in where it belongs, and you just keep adding to it. And that is one method of graphing sinusoids. So we're going to try some. So in lesson 84, it wants us to do number 8. So number 8. So this says the midline is -1. I'm going to try to do it the way the book does. The midline's -1. Here, let me just write it on my paper, and then I can put the paper where you can see it better. Y equals -1 plus 8. The amplitude's 8. Sine of 2x minus 45. So if I do it the way your book is wanting me to, then I'm going to start with the midline. And this here is not the y-axis. This is just a scale off on the left-hand side of my paper. I can add the y-axis in. Sometimes I choose not to even put the y-axis in, but this is kind of going to be my midline right here. I'm not an artist. It's going to look pretty bad. My amplitude is 8. So if that's -1, then I guess this would be 0. So I could put my x-axis in if I wanted to, right? So, and then there would be 1, 8. So I could, it does make sense for me to actually put my x-axis in. There's my x-axis. And then so that's, should be 7 right there. What? I wanted to go up by 8, so 1, 2, 3, 4, 5, 6, 7, 8. So this is 7 right here. That top one's 8, counting by ones. This gives me the period. So this kind of says that there's two cycles for every 360 degrees. Or in other words, I can go 2 is equal to 2 pi over b. Wait, sorry. I can get the period by going 2 pi over b, which is 2. So the period's going to be pi, which is kind of what I said. It will do two cycles of this will happen every 360 degrees or every pi degrees. Oh, you can't see that. Okay, there. So I think I'm almost ready to sketch my sinusoid. I guess I want to, if the amplitude is that, I need to probably go down by 8. 1, 2, 3, 4. So that would give me -9 right there. And then I'm doing a sinusoid, so I guess it feels so weird doing it like this, but I guess I'm just going to make a sinusoid. So ugly. Horrible. Okay, so there's my sinusoid. I just made it have a really big amplitude because it says the amplitude's 8. And then I know sinusoids, like let's get a little tiny picture of y equals sin x. Y equals sin x just looks like this. That's one cycle of the parent function y equals sin x. Okay, so this thing has a phase shift of my parent function got moved to the right by 45 degrees. So in other words, oh, and also the period, remember, is going to be the parent function's period is 2 pi. The period of my function is going to actually be pi. So one cycle could happen, you know, between there and there, but since it shifted over to the right by 45, I could say that maybe this, I can just label it how I want. I'm going to say this, wait, oops. Well, no, that's right, 45 degrees. That's my midline, though. Don't let me forget that's my midline. I'm going to make dots on it, too. So make points. So that's my midline. And then, so this would be the end of the cycle, right? So it would go up and down. I'll trace it out. Okay, so the end of the cycle between, am I supposed to be in radians or not? Let me check what I'm supposed to be in. I'm supposed to be in degrees, so we're good. So 180 plus 45 is 225. I'm going to put part 2 of this because I'm running out of time. So I will stop this video and make part 2 in a second here.